Hello, this is Physical Science, Chapter 10, Lesson 4. Physical Science, Chapter 10, Lesson 4. And we're going to start with converting these particular examples on your word map. You should be able to use the formulas that you see up above, and it will help you be able to convert those a lot easier. Check your work here after you convert them. Number 1 should be about 52 degrees. Number 2, another 52. Number 3 is 32 degrees, and number 4 is 8.96 degrees. Alrighty. So, what is temperature really? Atoms are in constant motion. Even in a solid, they're always making that jiggy, doing that jiggy. This back and forth jiggling is caused by what we call thermal energy. Temperature, as you already know, measures the kinetic energy per molecule, the random kinetic energy per molecule. Thermometers, here's how they work. Thermometers is an instrument that measures exact temperature. Most thermometers contain either a silvery fluid, which is mercury, or a red fluid, which is alcohol, containing a small amount of red dye. How they work. The volume of the alcohol in the thermometer contains a huge number of alcohol molecules. As the temperature increases, the alcohol molecules move faster and bounce off each other and start to travel up the tube. Each liquid alcohol, the liquid alcohol expands to take up more space because they're bouncing off each other. And they'll go up the tube, and that's what you read. Measuring temperature. A thermistor is a device that changes its electrical resistance as the temperature changes. Some devices, like digital thermometers, they measure the resistance of the electrons, how fast they flow through the wire. That measurement can give them an exact number or the temperature. Some digital thermometers sense temperature by measuring the resistance of electrons. Liquid crystal thermometers. Typically, you see these if you have a fish tank. They're usually like on the side of a fish tank. Some thermometers contain liquid crystals that change color based on temperature. As temperature increases, the molecules of the liquids bump into each other more and more. This causes a change in the structure of the crystals, which in turn affects what color. Absolute zero. Absolute zero is negative 273 degrees Celsius. You cannot have a temperature that is lower than absolute zero. Absolute zero is the temperature at which atoms are frozen. They're not really frozen, but basically the amount of kinetic energy that you can measure is next to zero. Viscosity. The resistance of a liquid to flow. Viscosity is determined by the attraction between the particles in the liquid. Both liquids and gases can spread out, and they are classified as fluids. They both also will have viscosity. In this example, you can see that the different liquids that are being poured out to the right have different viscosities. The thicker the liquid, the higher the viscosity. The more runny the liquid, the lower the viscosity. There are 4 states of matter: solid, liquid, gas, and plasma. The most common state of matter in the universe is plasma. Plasma is the stuff that our sun is made of. Let's look at these states of matter and how they kind of look different. On the top left is a solid. They make strong bonds and are held together. Remember, they're still jiggling around with thermal energy a little bit, so they're moving a little bit. As you increase that speed, increase that pace, it becomes a liquid. And that means they can flow past each other, weaker bonds. As you increase the speed or increase the temperature, it can become a gas, and then eventually high energy ionization or plasma. The states of matter are physically different. Gas is free to spread in all directions, and gas can exert a pressure. Solids, as you know, have a rigid structure. Liquids take up the shape of the container. The difference between each of these is energy. The amount of energy in a solid is different than the amount of energy in a gas or a liquid. It's all about energy. Let's quickly review this. All matter is made of tiny atoms and molecules that act like tiny particles. These tiny particles are always moving. The higher the temperature, the faster they move. At the same temperature, more massive particles move slower than less massive particles. It's all about energy. Energy is the ability to change or move matter. It's the ability to do work. Energy cannot be created nor destroyed. We call that the law of conservation of energy. Energy is either used to do work on molecules, moving them in or out of crystal lattice from when it's melting until it turns to a gas. Alright, this is the end of lesson 4. Phases of change. We're going to be doing the water lab next, hopefully. So as matter changes, the state of phase of energy must be added or taken away. This is the end of lesson 4, physical science.